As promised, I wanted to continue working on this question number 7 from our class activity number 7. Ah, that works out nicely. It's class activity number 7 from section 2.6, question number 7, because we didn't get quite all of those. Number 7 had these 10 examples, and let's talk through each of these, determining the interval on which the function is continuous, and then also this practice of writing answer and interval notation. So number 7a, we already did that. We did do that one in class. We said that it's continuous for all real numbers. So in interval notation, that would be negative infinity to infinity. And the reason why is because it's a polynomial. Letter B is continuous from negative infinity up to 5, but it's not continuous at 5 or greater, because when we look at the domain, we'd have, let me highlight it so you can see where I'm talking. When we look at the domain, we'd have that 5 minus x, this radicand, has to be greater or equal to 0. And when we solve that for x, we'd subtract 5 from both sides and have the opposite of x is greater than or equal to negative 5. And then when we divide both sides by a negative 1, we'd flip the greater than or equal to a less than or equal, and we'd have x is less than or equal to 5. So the domain is that x has to be less than or equal to 5, and that's negative infinity to 5. So for number 7b, the interval on which the function is continuous, it's continuous from negative infinity up to 5. Letter C looks like a polynomial, but when you look more closely, we see that this x to the negative 1 is actually a rational. Let me get a color that'll stand out. So x to the negative 1 is 1 over x. So we see that x can't be 0. And that's why the way that we write that in interval notation is we say, like on a number line, it would look like this. On a number line, we'd have our 0. We would highlight anything up to negative 1, but we'd skip over the 0, right? We'd highlight anything up to the 0 and then skip over the 0. In interval notation, the way that we note this is we say we stop at 0 and exclude it, or, so that's the union symbol, pick up again from 0 on the other side of 0, but notice that 0 is excluded. For letter D, when I work this one out, I could factor the 4x squared minus 100, noticing that it's a difference of two squares. 2x times 2x gives us 4x squared. So 2x squared minus 10 squared. So I can factor it 2x plus 10, 2x minus 10. And where do we get a problem? It looks like we get a problem when 2x plus 10 equals 0, which is when x is negative 5, or when 2x minus 10 is 0, which is when x equals 5. So for this one, we've got to exclude the 5, and we've got to exclude negative 5. The way we write that in interval notation is we say that it's continuous from negative infinity to negative 5, or negative 5 to 5, or 5 to infinity. For letter E, 4x squared minus 10 over x, we see that this is continuous except at 0. And so we'd write that in interval notation, negative infinity up to 0, or 0 to infinity. This union symbol means that it's continuous on this interval, or, the union means or, the second interval. Letter F, cosecant of x. This one's a little more challenging. It really, I shouldn't say that. I shouldn't say it's more challenging. It's just maybe you have to think a little bit harder about it. But here's how you could approach this. The cosecant is the same as 1 over sine. And so we can see that the problem with continuity is going to be if sine is equal to 0. So when does the sine equal 0? On a unit circle, that's when we have the y is equal to 0, right? Because sine maps up to y. So at this point on the unit circle, and at this point, so at the sine of x equals 0 when x is 0, when x is pi, when x is 2 pi, and we could keep going around this unit circle with an infinite number of values. So I'm just going to say any multiple of pi. So at pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, etc. And the way that we could write that is we could say that where is it continuous? It's continuous everywhere else. So let me draw another unit circle here to show you. Where is it continuous? I'm going to highlight where it's continuous. After we get past the x equals 0, we're continuous in all of this realm, right? But then when we get here, it's not continuous, but we're continuous here, and then we got a bleep, and then we keep going. It's continuous here, not continuous at this one point, and keep going. And the way we'd show that in interval notation is the way that we'd show this little interval. And by this, let me highlight it. I mean like this little blue thing. The way we could show that is from pi, let's start right here, from any multiple of pi. So 0 times pi would be starting right here. And anywhere along here up until we get to 1 pi. Once we get to 1 pi, we've got to exclude it. And then we could keep going. Any of this up until we get to 2 pi. We've got to exclude 2 pi and so on. So you may remember from your pre-calculus that the way we note that is by using the interval notation like this, where we're saying that k is an integer. And then finally, the last example, g. What's really interesting about g is that if you look at this x squared plus x plus 1, it doesn't factor, and x squared plus x plus 1 never equals 0. So for that reason, there's no solution to this x squared plus x plus 1 equals 0. So what does that mean? The denominator is never 0. So it means that the domain is all real numbers, or to answer our question, determine the interval on which a function is continuous. It's continuous from negative infinity to infinity, because there's no hole or jump or any other kind of problem. H, the square root of x squared minus 25. If we looked at that x squared minus 25, and this is a really important review from pre-calculus. We know that this has to be greater or equal to 0. Do you recall doing this? The way that you do this quadratic inequality is we factor. And then we look at the number line. We put down our -5 and our 5 on the number line. And it's okay for when x equals -5, because then we have a 0. The square root of 0 is just 0. Or when x equals 5. So we're going to have solid lines there. But we're looking, in each of these intervals, is the product positive or negative? So let's take some test points. If we took a -100 in this first interval, a -100 squared is positive, minus 25, and that comes out positive, right? Or a -100 plus 5 is negative. -100 minus 5 is negative. When we multiply those, we get a positive. Pick a test value in here, like a 0. 0 plus 5 times 0 minus 5 would come up negative. And that, you know what, I'm looking at this now. Let me go back. Will you excuse me for this error I just made? I don't want to edit the video, so I'm just going to go back and do this correctly. Sorry about that. I'm doing it too quickly because I'm watching the clock. If I put a negative 100 in, negative 100 plus 5, we're going to get a negative number, right? And then negative 100 minus 5, we're going to get a negative number. And when we multiply those, it comes out positive. Try it with a 0. 0 plus 5 is 5 times 0 minus 5 is negative 5. So we come up with a negative result. And then pick a number in this interval. And we'd say that on this interval over here to the right, pick a number like 10. 10 plus 5 is positive. 10 minus 5 is also positive. So when we see this, we can see that the problem with the domain seems to be when x falls somewhere between negative 5 and 5. So what we get here with this problem is we see that it's continuous. Let me highlight on here where it's continuous. We're continuous from negative infinity up to negative 5 because we're positive, right? So this, what's inside the radicand is okay from negative infinity to negative 5, and then again from 5 to infinity. I did this problem earlier, but I actually copied the problem incorrectly. I had it 25 minus x squared, but the way it's printed is x squared minus 25. So if that inside the radical was 25 minus x squared, the answer would have been negative 5 to 5, including the endpoints. But the way it's printed on your sheet, the answer should be negative infinity to negative 5 or 5 to infinity. Okay, the last two. I and j are both all real numbers. We're continuous everywhere. And why? That's a quick, easy one. And the answer is in this riddle. What did the mama bird, and let me give you a further hint. The mama bird is like a parrot, a domesticated bird. Often, those birds are called poly, aren't they? What did the mama bird call the baby bird? So Polly is maybe the baby bird's name. When Polly was sent to bed with no dinner. So here's the riddle. I know it might be really bad humor. You're like, that's not funny. But if you're going for that extra point I said I'd give you. Polly, when you go to bed with no dinner, you go to bed with no meal, right? Skipped your meal. That's the hint. So I'm not going to answer it, though if you're like, I don't get that at all, send me an email and I'd be happy to help you one-on-one with it. But I hope that this short video helped fill the blanks with any of these examples that you needed just a little more help with, and hope that this helps prepare you for the upcoming test.